Alan Kepper, thank you very much for joining us today.
No problem at all.
I was very interested to hear about a project that you've been working on with St. Joseph's Nudgee College. It sounds like it's been a very broad and deep development that was based around some very interesting wireless planning and strategies. Really has revolutionized the way that the kids are learning. Tell us a bit about the environment and how you were engaged in the project.
Well, Nudgee College is, it's a school that's it's a fairly large school, a lot of students, something like 1,800, 2,000 students, and I guess over the last 10 years they haven't upgraded infrastructure substantially. Things were fairly reliable and they were happy with it. So they're running Novell for the email and storage and all those traditional IT systems. They had a reasonably slow internet speed, which was okay for them at the time. Slow being 20, 30, 40 megabits per second. And I guess it came to a point mid last year where the executive decided that they needed to step up in the delivery of learning content and use new technology to do that. So they also had IT infrastructure that was maybe 10 years old, and they needed to update it and upgrade it and so on. Some of it wasn't supportable, and so I guess they started a project to update it all, and they decided to look at the whole infrastructure, how they would roll it out, and how they would also engage the teachers and the students in that process as well.
So it definitely was a very ambitious project necessarily with a very large scope. They decided ultimately to go to Google Apps. How did that happen, and I guess what did that mean for you guys in terms of delivering a service that was reliable?
Well, with Google Docs and the other Google services, it was attractive to them primarily for costs, but also it was also operationally was going to be much simpler. So effectively moving everything into the cloud meant a simpler thing for them to operate, and that I think had some benefits for them, or they were going to get some benefits out of that. The Google Docs being quite cost effective also, I guess, played into the part of the upgrade that was needed. They were looking at alternatives such as the traditional server, maybe a Microsoft core, that sort of stuff. And so they looked at all those options and they decided that the Google Docs thing was right for them. And if you listen to the teachers, if you listen to the executive at Nudgee, the IT and the IT guys, the ability to, I guess, work in the modern world is something that they wanted to push to the students. That means collaborative working and things like that. So the Google Docs thing really, in their mind at that time, was the best choice. So from an infrastructure point of view, and I guess from their skills point of view, everything had to be effectively, well, the school had to be jacked up, and then the whole new infrastructure had to be inserted underneath, and then the whole thing needed to be put back down again. So in that, they had to upgrade the core service systems, or move the core service systems into the Google Cloud. They had to upgrade the core network, upgrade the wireless network, but also all the security and the authentication systems. So effectively, they had to drop the whole Novell thing as well. So it's quite an ambitious project, and it wasn't. It was well planned, I think. Sean and David at Nudgee had 6 months to plan this out. It involved the human side of things too, because there was such a big shift in, I guess, from the old to the new, that they had to get involved, some teachers to see if it'll work, and so they picked some teachers that were leaders, got them involved early. They adapted how they taught, and in the new year when the kids all started, it seemed to roll out quite seamlessly. And I guess that from my point of view as a technologist, I found it quite interesting to see how quickly they adapted and adopted it. The kids took to it like that, some of the older teachers, older not being an age, but embedded in their old ways, actually came around within a couple of weeks. It was quite dramatic, and now it's so critical, and it's typical of these infrastructures. So I get, the Google thing was important. They also had they found an app called Hapara. Hapara was key for them because it allows the teachers to have control on what the students are doing. So this app lets them control emails, passwords, and things in the classroom. And soon it'll involve the parents and people like tutors and things that are around the kids, so that they can log on and see what they're working on and so on. Teachers and parents obviously can liaise over this system as well to check on marks and how they're going and how are things handed in and all those sorts of things.
It really sounds like a very integrated learning environment. They've been able to provide the Google Apps as the interface, and then provide the supporting tools for the teachers. As any teacher knows, I think one of the very defining characteristics of technology in the classroom has been the fact that usually half of it is broken at any given time. Certainly a lot of the lessons involve trying to fix things instead of doing the actual teaching and learning. Obviously, when you do this in a modern environment, you want to make sure that doesn't happen as much as possible. How did you go about ensuring that the configuration of the systems, for example, would stay rock solid and that the network would always be there, and that these sorts of issues would not be a problem at all? Obviously, this speaks to issues about coverage, for example, but there's probably a lot more to it as well.
Yeah. So the key thing about, I guess, a BYOD environment, especially, I call it BYOD version 2. It has to be mission critical. We've built quite a few for schools and corporates and things, but we have maybe 5 or 6 clients now that run what I call mission critical BYOD 2 type systems, and that is, it's in fact the whole network and the wireless system is more critical than the servers. And it's not that simple, but it is that critical. So we have a number of schools, for example, where if the wireless stops, everything stops. So it's not normal, but that's the way it's going. So to do that, we had to redesign the core network to be resilient and provide good quality communications. That involved upgrading a few bits and pieces here and there. It wasn't a huge expense, but it had to be done. And that meant breaking it up into many different subnets, breaking it up into year levels, house levels, or things like that. So you break up the traffic so that it can communicate to the core more quickly. The other part of it is we had to put in some very fast authentication and security systems, because with kids getting on the net and users generally, you need to track what they're doing and how often and so on, meter the amount of traffic, and even maybe control it. So we had to put in some pretty fast systems. We used a couple of products from Fortinet, and the internet speed was a critical thing too. So in that, they upgraded to a gigabit link, and down the track they'll probably put on a second. But we're seeing some schools hook up at very high speeds. We have a couple of clients now on 10 gig internet links, and I see that continuing. So obviously then, once we had the core sorted out, the authentication, the core network and the security, we then overlaid that with Wi-Fi for the main access technology. We used a technology from a vendor called Xeris, and that allowed us to get access to the 802.11ac technology, which is really a future-proofing technology. Nudgee wanted to put this in and wants it to last 5, 6, 7 years, rather than replacing it multiple times in the near future. So to do that, we have to go through our standard wireless process or processing, the engineering process, I mean, where we have to do a bunch of surveys. And when Laminar rolls these things out, we typically offer a guarantee, so that once we've done our engineering work, if it doesn't work, that's not the client's problem, we resolve it. And so that involves surveying, engineering, and then when we're finished, we actually survey again to validate what we've done. There's a bunch of side effects that or benefits in us doing that process. For example, knowing the RF propagation in every room, that sort of thing is useful for any HR issues down the track. But we also know the performance of the network at any time, and if something goes wrong, we know what it should have been, and hence we know the difference. If there is a difference, we know where to chase it. So at the end of the day, we're able to guarantee, signal strength, performance, that is data rates and those sorts of things. Also bit error rate and all those sorts of engineering things to make sure it all works properly. We also built into there a number of tests for operations, so we can wander around the campus and instantly do a test to figure out if the network's working properly. And that allows us to, if there is an issue, figure out what's going on. So with those 4 or so things, we're able to build a really resilient network, and the AC capability and the technology allows us to build some future proofing into it. The thing about BYOD is the kids roll into school. Well, they did this year, for example, with the latest iPad, iPhone, whatever, Google laptops and things like that. Next Christmas will be another wave of products. So I know the next wave of products coming from Apple will all be AC capable. And so we're talking about speeds of 1.3 gig now at the access point. So we've got 2 1.3 gig radios sitting in these access points, or these, we call them arrays because we have many radios in them. And that speed, moving out to all the laptops means the whole classroom moves much more quickly. That is from a data rate point of view.
Definitely.
A lot of that gets funneled into the core, so we've had to make sure that the core will be able to handle that. So again, lots of 10 gig core kind of connections and things like that.
Definitely the aggregate bandwidth is a real issue, as you mentioned, with the AC devices becoming more common, and certainly at Christmas time a lot of people will get those sorts of devices. Are there characteristics of the AC technology that allow you to better manage this sort of surging bandwidth, I suppose? And clearly, when you start having more than one device per student, it becomes an even bigger issue. How do you manage that and ensure that next year's flood of AC devices is not going to overwhelm the network?
There's many facets to it. There's the connectivity. We have to design things, simple things like even DHCP servers that allocate the addresses, and the subnet sizes and things need to be carefully considered because we currently designed 4 devices per student, but at some universities and things they're actually moving to 5 now. And so that changes a lot of the traditional dynamics of the network. The network no longer, well, you might imagine that you've got 5 devices but only one's being used, but you still need to provision for it. So the design has to change a little to accompany that, or to accommodate that, I mean. So with the speed and with the likes of the AC technology, the key thing is it allows more devices to connect at higher speed. So that means the whole cell, or the environment where all those kids are communicating or users are communicating, means the whole thing moves more quickly. Now, that means more devices per cell, and it means that you obviously need the backhaul as well, but the whole cell will move more quickly. Currently, at the moment, there are a lot of legacy devices, such as 802.11b, which automatically limits the cell to 11 megabits per second. As soon as it jumps on, everyone's at 11. With the likes of AC, they can communicate at 1.3. Imagine it like a highway. You've got a nice fast Ferrari driving down a single lane road, and an old lady pulls out in a Morris Minor. You've got to wait for her to hop off before you can get back on, if you know what I mean, or get back onto the speed. So as more of those Morris Minors leave the road, it means that the whole highway net throughput is much quicker. So what it means is the devices are on the air for less time, and that means less spectrum density, better quality, and so on. So that's where the AC benefit comes.
and you're able to manage that contention better and ensure there's some more consistent performance to the classrooms, which obviously in the end is the key thing.
So the key thing is that we always have this technology migration, kids bring in the latest widgets, so we need to manage fast devices and slower devices. So we've got means of doing that. In fact, the Xeris gear is probably the only gear in the world that you can do that well. And that's because it has many radios, and each radio can be assigned to a different class of connectivity. So we could put all the slow devices on a slow radio and all the fast devices on another radio so that they have a great day.
Fantastic. Well, it certainly suits the operating environment. With such an investment in cloud, certainly there's a change in the types of traffic that, you know, it obviously used to be very client-based, and now we have a very significant server component with the cloud elements. That's increasing, no question. I know the school is backing up to the cloud as well. Is that going to affect the way that the devices perform and the network performs as that traffic shifts and we're doing more and more in the cloud?
The network traffic is more web-based, and so it's very different than client-server based. So a lot of the traditional client-server heaviness occurs, you know, in the Google data centers effectively. That's a gross generalization, but and so the web traffic being more asynchronous, as I like to call it, means there's more ability to contend for bandwidth. So it's more efficient in contending with bandwidth. So they have for example, Nudgee has a 1 gig link to the internet. They're currently chewing up about 3 or maybe 30–40% of that. So as the teachers, and I think next year we'll see an increase in that because the teachers will, over the holidays and over their break, come up with new ways of delivering content. So, and their teaching efforts. So I think, and from what I've seen at other schools, it'll probably creep up to 60–70%. So the guys at Nudgee know that, and so they'll be looking at another link shortly.
Sounds like everyone's on top of it to ensure that there's a very good education experience. Alan, I really appreciate your time today. Thank you very much for sharing your experiences at the school.
No problem at all. Thank you.